Okay, so now use it practically. Okay, don't just robotically memorize. That's how you calculate, but know the meaning of it. Now, if you have this direct mixing deal or this solution, and this is a complete cell, electrode cell. So your reference in this case, you need 2 half reactions, right? So this is your reference electrode. So this is 0, right? So this is not going to contribute any potential. So whatever you read here is will come from this reaction, half reaction. So you use silver wire as the conductor, then it will participate in a reaction. So this is your couple, okay? Your redox couple. So let's say experimentally, okay, you measure a potential of 0.692 volt. So this is experimentally determined. You measure. Then from that, you can calculate the molarity of this solution. Okay, so now step number 1 is to pick the suitable half reaction. So this is it. And the E naught from the table is plus 0.8 volt. So use that for number. Then now you use the Nernst equation. So this is what is experimentally measured. Okay, you plug that in. So now you know the meaning of it. Okay, and then plug in the E naught and then the formula here for the Nernst equation. So silver, metal, low concentration. So as you can see, you have just one unknown to solve for. Unknown right here. So do the algebra, then you will be able to calculate. This is equal to 10 to the minus 2 molar. Yes?
Won't that go down as you start doing it? So where do you check your, when you get your E, when you measure your E? Because this should start going down, right? As your concentration starts to react with your electron.
You have no, here, be careful that you are not doing the 2 separate. The 2 separate solution, you have electron transfer. So electron, the delta potential initial, then it will go lower and lower. But in this case, your concentration is fixed in here.
Yeah. You're saying there's a salt bridge in the middle that's going to replenish the amount of ions in the solution.
Yeah, but the electron is not going to consume.
Right.
Yeah.
Okay.
So it will stay. It will stay. Yes.
The difference, what's the difference again? I think you already said it, but the difference between the 2 E values? Like, how did you know one was 0.692?
Well, this is a Nernst equation, and this is an experimental whatever, the potential. So in a previous example, you calculate for that based on your knowledge of concentrations. But now here, you measure that, and then from there, you calculate the concentrations. So doing the opposite.
Okay.
They mean the same thing, but that's doing the opposite. Yes, Jessica?
The one under the Ag plus, where is that coming from?
Solid.
Well, the Nernst equation.
No, the one under the.
It's a solid.
This guy, right?
Oh, okay.
Yeah. Yeah. Okay, Mr. Gaga. Gaga. It's a lady, a gentleman. Yeah, lady and gentleman. Yeah.
You think you're funny, huh?
Oh, I enjoy it. Yeah. Life, you never know. Life, hopefully, is good all the time and keep smiling and laughing. Yeah. Okay. Then this could be an analytical technique, right? So you are looking at a linear relationship, right? Whatever you measure by changing the concentration. So if this is a standard solution, a series standard solution, right? Then corresponding to a potential. Then your calibration line based on standard, could be negative, could be positive. It depends on this concentration. Okay, so this concentration usually is less than 1, then it will be a negative slope. So once you get a calibration line, then you can run your unknown. Your unknown gives you the potential, then potential versus concentration. That's how you get your unknown concentration. Okay. Okay, so if you are given this half reaction, so to represent this half reaction, now look at that half reaction. There's no conductor. So this electrode half reaction, you will need to have a conductor. So to your knowledge, then you use platinum for simplicity. Okay, so you will need to have all these chemicals in it in order to have this half reaction to go. Okay, so all these chemicals in it. As an example, then you dissolve a particular chemical to give 0.1 molar, and for convenience also 0.1 molar, and then H comes from perchloric acid. Let's make it 4 molar. Now for this particular chemical, you can get from a chemical storeroom, knowing that is a +1. Okay, so so this is going to be associated with some kind of anion, and this one associated with some kind of anion to dissolve. Okay, so in case this reaction goes, if you are asked to calculate what will be the potential based on this experimental condition. Okay, so this is the question. So you will use your Nernst equation as usual. So this is your Nernst equation. How to treat with the acid? Well, the acid is on the left. So whenever it's on the left, then it's a plus. If your acid, your H plus is on the right, then it is going to be minus. So on the left, so it's plus. Also 0.059 log concentration to the power 2, because the equation has a 2 in front. So this is your plug in all the way, okay, with the 2 in front. So on the left, then this is your experimental potential, okay? So experimental potential in this case is greater than the standard potential.
Why are you squaring that, the H plus value?
Right there, coefficient. Okay. Okay, so this is a review, the basic example that you must need to know. So combine the two half reaction into one complete reaction, right? So you write the more positive one first. Okay, then followed by the last negative one. Then you subtract to make the bottom one. When you subtract, automatically the bottom one is going to switch into oxidation. Okay, then followed by balance for the number electron. So balance the 2. And then particular attention, do not multiply the E naught by 2. So this one, the whole deal multiplied by 2, except the potential is not multiplied by 2. And therefore, you end up with this overall reaction, and it's spontaneous, because after doing this, then you get a plus sign. That means it's spontaneous. Okay, as long as you see the plus sign, then it is spontaneous reaction. So the minus, okay, what does it mean? So that means the E overall, this is your overall is equal to, so this the E overall is equal to the E naught reduction, so the top one is the reduction, minus the bottom one is also reduction. Okay, now minus meaning switch, right? Minus, change. Therefore, this is equivalent to this. The bottom one becomes oxidation. So now you get a redox reaction composed of the two half reactions. Okay? So this is your basic overview.